AP 120, Chapter 2. The topics are acids and bases and inorganic and organic compounds. So, electrolytes. What are electrolytes? Electrolytes, it turns out, are substances that release ions in water. So, electrolytes are things that dissolve in water and release ions. So, for instance, good old salt, sodium chloride, put that in water, it will dissolve, giving you sodium ions and chlorine ions. The ionic compound breaks up into its ions, and this is because of water's polar nature. So, because water is slightly positive and slightly negative, it's able to break apart uh, the ions within the sodium chloride crystal. And so you have the negative oxygens attracted to the positive sodium ion and the positive hydrogens attracted to the negative chlorine ion. And electrolytes are found all over the place in the human body, in blood plasma, in the fluids surrounding the cells, so the interstitial fluids, and inside of cells, and even other places. All right, acids and bases. Well, an acid is an electrolyte that releases hydrogen ions. So acids and bases are electrolytes. Acids release the ion hydrogen. So, for instance, hydrochloric acid, when put in water, will uh, release hydrogen ions and chlorine ions. So it is an acid. Bases are electrolytes that release ions that combine with hydrogen ions. So bases will dissolve in water, it's usually what we're talking about, and it will release ions that combine with hydrogen ions. The most common kind of ion released is hydroxy ions, OH negative. So for instance, we take sodium hydroxide, dissolve it in water, and we get sodium ions and hydroxide ions. And that OH negative can combine with the H positive. It gives water. So just so you know, in general, with the molecular formulas and electrolytes, the hydrogen, if it's on the right side, will dissociate and be a hydrogen ion all by itself. So hydrochloric acid, hydrogen's on the right, break it off. Now you got hydrogen ion and chlorine ion. And if the hydrogen is on the left side, it's usually part of some bigger ion. So sodium hydroxide, when it's dissolved, gives you the OH. OH. Hydrogen is staying with the oxygen because it's on the left side. So this is just a way to try to help you know when the hydrogen is going to be a hydrogen ion versus some other kind of ion. And again, I'm doing left and right based on my patient's view. So this is the right side of the patient. This is the left side of the patient. All right, pH. pH is a measurement of the concentration of hydrogen ions. So how much hydrogen ions are present in the solution. And the more hydrogen ions, the more acidic. pH runs from 0 to 14, 0 being the absolute most acidic possible, 14 being the most basic or alkaline possible. So pH 0 is pretty much all hydrogen ions. pH 14 has no hydrogen ions. And then it turns out that pH 7 is viewed as neutral, as being neither acidic nor basic. And that is the pH of distilled water, pure H2O. The pH gets smaller, the amount of hydrogen ions increases, becomes more acidic. As the pH number gets bigger, the amount of hydrogen ions decreases, making it more basic. And here's just a few common things that you might know about and where it falls in the pH scale. So gastric juice, stomach juice, very acidic, pH 2-ish. Tomato juice is actually rather acidic. It's 4.2 or so. Cow's milk is slightly acidic. Blood is slightly basic or alkaline. Tums, that antacid, so it's alkaline or basic. It's opposed to acids, it's a base. And then drain cleaner is super basic. Breaks things down amazingly well as a super high concentrated base. So again, extremes of the pH are extremely dangerous. Right. When we talk about compounds, again, compounds are molecules with two or more elements in the molecule. We have a category referred to as organic. An organic compound has both hydrogen and carbon. It can possess other elements, but it must possess both hydrogen and carbon to be organic. So CH4, good old methane, that is organic, has carbon and hydrogen. CH3OH, good old methanol. Methanol is also organic. It has carbon, it has hydrogen. Oxygen's there as well. That's great. Hey, oxygen. Anything else, all other compounds viewed as inorganic. So everything else is inorganic if it doesn't have carbon and hydrogen. So here are some molecules here, and I'm going to give you a moment to determine which ones are organic, which ones are inorganic. Pause the video if you feel you need to. All right. Turns out that water, H2O, is inorganic. It only has hydrogen. Carbon dioxide, CO2, is inorganic because it only has carbon. NaCl is inorganic. It neither has hydrogen or carbon. Both are missing. O2, molecular oxygen, is inorganic. There is no carbon, no hydrogen. If we look at these other molecules, we see that glucose, C6H12O6, is organic. It has carbon and hydrogen. Ethanol, C2H5OH, again, has carbon, has hydrogen. And sodium bicarbonate, NaCO3H, has carbon and hydrogen. Doesn't matter how much carbon and hydrogen, you just have to have at least one carbon and at least one hydrogen to be organic. All right, some important inorganic compounds include water. Water makes up about 2/3 of our overall weight, so we are approximately 2/3 water. So compared to some other living things, we see that potatoes are about 80% water, tomatoes are about 95% water. Water is important because it is a solvent. It is a solvent. It dissolves things. Not everything, but a lot of things can dissolve in water. The things that dissolve in water are known as solutes. So solutes dissolve into solvents. And then when that happens, you get a solution. So a solution is something that is dissolved in something else. So for instance, you dissolve salt, sodium chloride into water. Solute sodium chloride, solvent is water, gives us the sodium chloride solution. And it turns out that nearly all metabolic reactions occur in the presence of water, making water extremely important for us humans. All right, so here is a beaker filled with 10% glucose solution. We have a 10% glucose solution. What is the solvent? And what is the solute? Well, the solvent is water. For this class, the solvent is always water. Living things, mostly water. So for this class, the solvent is always water. The solute is what is talked about. So the solute in this case is glucose, 10% glucose. Solute, glucose. What's it dissolved in? It's dissolved in the solvent, water. And what percentage of this solution is water? Well, if it's 10% glucose and 100% is the max you can have, is actually what you have to have in total is 100%, well, then water has to be 90%. 100 minus 10 equals 90. All right, another important function of water is it is able to transport materials, things dissolved in it, things just floating in it, and it's also able to transport heat. All right, oxygen, another important inorganic compound. It's critical for life because it is used to release energy from nutrients. So the food we eat, some of that food gets broken down using oxygen to give us energy, to give us ATP, the chemical form of energy. This occurs in the mitochondria, the organelle called the mitochondria in cells, and is critical for cell metabolism. Carbon dioxide, CO2. Turns out carbon dioxide is a waste product from the production of energy in the mitochondria. So carbon dioxide is released during energy releasing reactions. It is a waste product that we then get rid of. Salts. Salts are formed by ionic bonds. Salts are composed of oppositely charged ions, and they will then be able to dissolve in water, and therefore they are also electrolytes. So all salts are electrolytes. All salts are things where you have oppositely charged ions ionically bound to each other. So there's a huge number of things defined as salts. The only other thing to remember is salts are not acids and bases. Acids and bases are not salts. So sodium chloride, dissolve it in water, you get sodium ion positive, chloride ion negative. Calcium chloride, dissolve it in water, you get calcium ions +2. It has 2 charges, and chlorine ions. And then sodium sulfate, dissolve that in water, you get sodium ions and sulfate ions. And that is it for this part.